Good day, students. You're welcome to today's class. Today we are going to be looking at current electricity, and to be precise, we are going to be considering Ohm's law aspect of it. And let's quickly run through the objectives of this particular lesson. By the end of the lesson, we should be able to solve simple problems using Ohm's law. Also, we should be able to solve simple problems related to internal resistance and lost footage. And probably we should be able to look at something related to resistivity and conductivity of a material. To start with, let's look at Ohm's law. Ohm's law states that voltage across a conductor is proportional to current flowing through it, provided that temperature and other physical properties remain constant. That is, in a given conductor, if it is a conductor that obeys Ohm's law, provided that we can make the temperature and other physical properties to remain constant, the higher the voltage, the higher the current. And mathematically, we can present this as V directly proportional to I, and in every proportionality statement, there must be a constant of proportionality. So that is why we are having a mathematical representation below, which is V equal to IR. And in this equation, R stands as the constant of proportionality, which is the resistance of a given conductor. Now let's see how we can quickly use this simple equation to solve some problems. Let's quickly consider this first example. In the first example, we have a torch lamp which takes a current of 0.3 ampere from a 3-volt battery. We have to calculate its resistance. Let's first write out the given parameters in this question. The parameters in this question are, we have current of 0.3 ampere, that is taken from the source voltage of 3 volts. We are looking for R, which is the resistance of the torch. Okay. Now, considering Ohm's law, which is V equal to IR, making R the subject of the formula, we have R equal to V over I. Substituting the values into this expression, or this equation, we have 3 divided by 0.3, and that is equal to 10 ohms. That is the current provided by the circuit of this torch, the resistance provided by the circuit of this torch is equal to 10 ohms. Let's consider another example. Now in this example 2, we have a filament lamp of a resistance of 12 ohms, which draws a current of 0.5 ampere from a voltage source. We have to calculate the voltage applied across the lamp. Let's quickly consider the parameters in this question as well. If you look at the parameters, we have resistance given and current is also given. We are looking for the voltage that is supplying the current. Considering making use of the Ohm's law representation, mathematical representation, which is V equal to IR, and substituting the value of I and R into that equation, we have V equal to 0.5 multiplied by 12, which is equal to 6 volts. Let's consider one more example before we move on. In our example 3, the question says, what is the value of current that will flow through a resistor of 5 ohms when a voltage of 3 volts is applied across its end? Now in this particular one, we have a resistance given as 5 ohms and the voltage at the source given as a 3 volt. We have to look for the current using the Ohm's law, I equal to V over R, and substituting the value of voltage and resistance into that equation. We have our I to be equal to 3 divided by 5, and that is equal to 0.6 ampere. Okay, let's quickly consider the second objective that we have our lesson, and this has to do with internal resistance and loss voltage. Now, first thing is what is internal resistance? Now, it is from general observation, when we set up a simple circuit with a source EMF of a particular value, and we try to use voltmeter to check for the voltage across the terminals of this circuit, that is checking the voltage across the loads in the circuit. It is always discovered that the voltage across the loads are always lesser than the EMF of the circuit, that is the voltage from the source. What is the reason for this? Now, the reason for this is because of the opposition encountered by the charges moving through the circuit, or probably the opposition offered by the material of the cell or battery producing the EMF. And this opposition is what we call internal resistance. And it is represented with small letter r. And according to Ohm's law, we can have a representation for this. Remember, we have Ohm's law stating that the voltage across a conductor is directly proportional to the current flowing through the conductor. But in this case, in order to harmonize the currents and also give room for the internal resistance, that is why Ohm's law is rewritten as a E, which is standing for the EMF in the circuit, that is EMF from the source, equal to V plus IR. Here, this V represents I capital letter R according to Ohm's law that we first look at. And why the I small letter r represents the part of lost voltage in the circuit, that is the voltage lost in the circuit while encountering opposition known as internal resistance. Now, putting all this together, we have new equation, which is E equal to I into bracket capital letter R plus small letter r, where capital letter R is representing the load in the circuit, while the small letter r is representing the internal resistance due to the cell or to the material in the circuit. And I is the current flowing through this circuit. And the capital letter V is the terminal potential difference, that is the voltage across the loads or in each terminals of the circuit. Now, let's quickly see a question related to this relationship. Now, in the question that we have in here, we have a battery of EMF 24 volts and internal resistance of 40 ohm, which is connected to a resistor of 32 ohms. We have to calculate the current across the resistor. Also, we have to calculate the terminal potential difference of the circuit. And lastly, we have to calculate the lost voltage in the circuit. Let's quickly consider the parameters given here. Here we have the source EMF, that is the EMF from the source that the circuit is connected to as 24 volts. And we have internal resistance of this battery to be equal to 4 ohm. And this circuit, we have a load of 32 ohms in the circuit, and that is capital letter R. First thing that we are looking at here is the current across the circuit. What is the current across the circuit? Recall that from Ohm's law, we have E equal to I into bracket capital letter R plus small letter r. Therefore, we can make I the subject of the formula. I equal to capital letter capital letter E divided by the sum of capital letter R and small letter r. Substituting the given parameters into this equation, we have our I to be equal to 24 divided by the sum of 32 plus 4, which is 36, and that will give us 0.67 ampere, which is the value of the current flowing through this particular circuit. Using the value of the current and the value of the load, 32 ohms, we can determine our terminal potential difference, which is equal to I capital letter R, that is the product of current and the load. And that is given as 0.67 multiplied by 32, which is equal to 21.33 volts. And lastly, to find the value of our lost voltage, our lost voltage is equal to I multiplied by a small letter r. And remember, we've calculated our current in the first part of the equation. Therefore, we can substitute that into the equation. And our internal resistance is given as 4 ohms. Substituting this into this equation, we have a 0.67 multiplied by 4. And this is equal to 2.67 volts. And with this, we are going to bring the lesson to an end. But just before we close the lesson finally, we'll quickly look through a particular book whereby we can see some other information regarding this Ohm's law. And the name of the book is Reform Physics Student Handbook. To have more information about Ohm's law, that is to see some other parameters, the definition of all the parameters, that is the current, voltage, EMF, and the likes, you can try and get a copy of this book that will be made available very soon on Amazon. You can easily go through the book and you can see the definition of a potential difference, the definition of current, and even the mathematical representation of each of these, how to calculate them using some given parameters. You can see the Ohm's law also stated in the textbook and some other examples. And aside from this, we have comprehensive explanation of internal resistance and lost voltage given here. Also some other parts that we are going to consider in our next video, that is conductivity and resistivity. And at the end of each chapters in this book, we have practice exercises that cut across past questions in WAEC, NECO, and UTME, both objectives and theory. Just try and get a copy of this book and try to solve some problems there. And if you have any questions, you can easily reach out to us. You can state your question in the comment section under this video. And if you think the video has benefited you in one way or the other, please try and like the video and click a subscribe button so that you will get some other videos whenever they are available. Thanks for watching.